assume a normal distribution. My sample has to be less than 5% of the population, but n times p times 1 minus p has to be at least 10. If that doesn't work, if n times p times 1 minus p is smaller than 10, what we will do is use a binomial approach. It's been a hot minute since we did binomial, but I think we'll do it. All right. So remember binomial, that was back when we had discrete data and we had a whole table for it. We had a formula for doing it by hand. So we had all kinds of options here. So let's look at this one. In 2006, 10.5% of all live births in the United States were to mothers under 20 years of age. A sociologist claims that births to mothers under 20 years of age is decreasing. She conducts a simple random sample of 34 births and finds that 3 of them were to mothers under 20 years of age. Test the claim at alpha equals 0.01 level. So what is my null hypothesis?
Equals 0.105.
Okay. What is the alternative hypothesis?
P is less than.
Right, because she said it's decreasing. Okay, when I go to check my criteria, 34 would certainly be less than 5% of the whole population. But if I do my n times p times 1 minus p, we get 3.195. So this means it is not normal. I cannot use the normal table and the z's to find this. All right, so our approach has to change. We still need our p-hat. P-hat is x over n, so 3 out of 34 is 0.0882. Okay, what we're going to do is find the probability that our x is less than 3. Okay, so we have the p-hat, but in order to be able to use z's, it has to be normal. Since it's not normal, I can't convert into z's. So what we're going to do is look at our x here. Probability that x is less than 3. So we have some options. We had a binomial table, but it only went up to 20. And how big? How big is our sample? 34, so we can't do that. We can do them by hand. Remember the whole n choose x and p to the x power and 1 minus p to the n minus x power. We also have a wonderful tool in our calculator that I never told you about for a reason. Okay, so if you hit second and this bars, that B-A-R-S, it takes us into some distributions. Did I hit second? Hold on. Second, and that button. Here we go. All right. I want you to go down. And you should get, there's binomial PDF and binomial CDF. So the PDF will only calculate one thing at a time. So if I just wanted to do x equals 3, I would go to that one. CDF is cumulative. So if I want everything less than 3, if I calculate 3, it will add up everything smaller than that. Remember when we had that table, we had a cumulative table? So let's go to the cumulative one. So trials, that's our sample size. How many trials do we have? 34. Okay. Then we have our P. What is the P that we're using? And then we have X. what was our X? So this calculates the probability of 0, plus 1, plus 2, plus 3. And we get this. Sorry, 0.5149. So would we reject? There's a 51% chance this happens. Would we reject? No, we only reject if it's smaller than alpha. That's greater than alpha, so fail to reject. Sorry about that, but now if you're gone tomorrow,